Okay, so here's E4. We're going to find the derivative of some functions, and we're going to have to use product rule with chain rule inside of it. And then later we're going to have to use quotient rule with chain rule inside of it. So here's the first example. So we've got g of t equals that. And so then according to the product rule, g prime of t is going to equal prime, no prime, no prime. I didn't leave enough room. Prime. Okay, so I got these four brackets, plus in the middle, prime on the first, prime on the last. That's the product rule. And now I'm going to put these inside. So 6t squared plus 5 to the third. T to the third minus 7 to the fourth. Third. Okay, now here's the thing, guys. To take the derivative of this, we need to use the chain rule, okay, inside, outside. And then this one the same, okay? So I'll just do it like under here. So inside, outside. So the inside function is 6t squared plus 5. The outside function is blank to the third. And then for this one, the inside function is t to the third minus 7. And then the outside function is blank to the fourth. So I'm going to have that g prime of t. The derivative of this is 12t. Okay. That's the derivative of the inside. The derivative of the outside is 3 blank to the second. Okay, but what goes back in the blank is what used to be in there, which is 6t squared plus 5. This just comes down. So this is t to the third minus 7 to the fourth. Plus, this one just comes down. 6t squared plus 5 to the third. The derivative of this inside is 3t squared. And then the derivative of this outside is 4 blank to the third. But what goes in the blank is what used to be in there to begin with, which is t to the third minus 7. Okay? Now, if you left your answer like this, it is totally fine. But if there's little simple things that you can, like if there's coefficients that you can multiply, then I would, you know, like on the AP test, like you wouldn't have to simplify it, but it's good to be in the habit of doing a little bit of like easy simplification, because when you go to college, your math classes in college would expect you to simplify a problem like this. But then also, if you're in a multiple choice section of the AP test, those answers would be simplified. So you want to be able to recognize, you'd want to be able to like match this to a simplified answer. So I don't know. Let me just simplify a little bit. So if you look like at this first term here, I could multiply the 12 and the 3. So what is that? 36. So 36t, 6t squared plus 5 squared, t to the third, 7 to the fourth. So, and I will simplify my answers like as much as I am right here. Yeah, so when you're checking your answers, you'll want to be able to know, you know, if you're right or not, when looking at my simplified answers, kind of simplified answers. So this is 12t squared, 6t squared plus 5 to the third, and then t to the third minus 7 to the third. Yeah, that's right. It's 12t squared. Okay. So there it is, guys. Okay. Now let's do this next one. Okay, so this time to take this derivative, we're going to have to use quotient rule. So I knew I needed to use product rule here because I was taking the derivative of a product of two functions. This function is itself a product of two other functions. This function here is itself a quotient of two other functions. So I'm going to use quotient rule. Yeah, so I'm going to have that s prime of t is, right, I'm going to have bracket, bracket minus, bracket, bracket, prime on the first, prime on the last, and then this is all over bracket squared. Okay, so this is t to the third minus 8t to the 1/4. Now, I converted this because since this bracket has a prime on it, I'm going to need to take the derivative. So I want to write it in the form a blank to the n so that when I do the chain rule in and out, I could use power rule like within that. So a blank to the n I want. And then here, t to the 10th. Now, I guess with this one, I mean, you could again do t to the third minus 8t to the 1/4, or you could just leave this one as the fourth root of t to the third minus 8t. It doesn't really matter, but you can just leave it like that because this bracket doesn't have a prime on it. You don't have to take the derivative of that. T to the 10th, t to the 10th. Okay. Now, I'm going to do my in and out charts off to the side, you know, because of this denominator. It's not really easy to do them right under those. So, in, out. Oh, I only need one. I only need to do chain rule on this derivative. This derivative does not need chain rule. That's just a simple power rule. So, t to the third minus 8t blank to the 1/4. All right, derivative of this inside is 3t squared minus 8. Derivative of this outside is a fourth blank to the negative 3/4. And then that goes back in. Okay, and then this derivative is just going to be 10t to the 9th. All right, so I've got s prime of t. All right, so this right here is going in for that, and then it's going to be times t to the 10th. So I got to multiply this by t to the 10th. So I'm just going to go 1/4 t to the 10th, 3t squared minus 8, t to the third minus 8t to the negative 3/4. It's just kind of nice to gather any monomials out front with the coefficients. T to the 10th is a monomial because it just has one term. Minus. Okay, now this derivative here, this derivative here, I guess I'll just like off to the side. So t to the 10th prime, this is 10t to the 9th. All right, so so all of this is like side work. So all that's like a side work. Again, this is a monomial, so I'm going to write it first. So 10t to the 9th times the fourth root of t to the third minus 8t all over. Guys, this is actually t to the 20th, but you could also just leave it as t to the 10th to the 2nd, or you could say t to the 20th. It's totally up to you. Yeah, so there's the answer there. All right, I'll talk to you later.